Let's solve the following physics problem. Describe the conditions necessary for the ions to pass through undetected. So let's describe the conditions necessary for the ions to pass through undetected. So the first one is electric field. Electric force must be equal to magnetic force. So that's the first condition. Electric force must be equal to magnetic force. Right. Condition number 2, the fields must be mutually perpendicular to velocity of ion. Right. So this arrangement shown is a velocity selector. Remember, a velocity selector. So let's move on. If the speed of ions as they reach the fields is 2.1 times 10 to the power 7 meters per second, and the magnetic flux density is 2.5 times 10 to the power minus 40. Calculate the magnitude of the electric field strength so that the ions are not deflected in the region of the fields. Right, let's try and attempt that question. So you're given that V is equals to 2.1 times 10 to the power 7 meters per second minus 1, and P is equals to 9.6 times 10 to the power minus 4 T. So from our equation, E is equals to VB. Our E is equals to, multiply these two, so 2.1 times 10 to the power 7 multiplied by 9.6 to the power minus 4. So our E is going to be 2.016 times 10 to the power 4 volts per meter. Right, we've solved that one. Let's solve the next one. The two, state the changes, if any, in the path of ions if the two fields state the change, if any, in the path of the ions in the two fields if the ionization of oxygen resulted in the removal of an electron. So when the oxygen was ionized, an electron was removed. So they want to know if the path of the oxygen ion will change. So typically, ideally, so in oxygen ion, when an electron is removed, so it becomes O plus. So the charge increases. The charge increases because the electron has been removed. But remember, our equation E is equals to VB. So in this case, the electric field didn't change. The magnetic field did not change. So if the electric field and the magnetic field did not change, there is not going to be any deflection. So there is no deflection of the ion. But if it was a magnetic field only or an electric field only, there was going to be curvature of the ion. But since the electric and the magnetic field did not change, there is not going to be any deflection of the ion.